Now we're going to talk about quadratic functions. And quadratic functions are basically polynomials with degree 2. Okay, so they're always going to be in the form of ax squared plus bx plus c. And when we graph polynomial functions, we always get a parabola. Now if a is positive, we say it's concave up. And if a is negative, we say it's concave down. And every parabola can be split into two equal halves by the axis of symmetry. It goes right through the vertex, and the vertex is either the lowest point or the highest point. Now the simplest form of a parabola is when you have ax squared, and that means that the vertex always goes through the point 0, 0, and then it goes to the point 1, 1, 2, 4 if a is 1, and depending on what a is, it'll make it either go up quicker or slower if a is between 0 and 1, or if a is negative, it makes it go down like that. So if a is 1, then I've got f of x equals 1x squared. And that's our parent function. So let's talk about how that works. So as I said, we've got a vertex at 0, 0, and then we've got a point at 1, 1, 2, 4, 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And because of symmetry, everything matches. Let's see, my origin's off a little bit, isn't it? Everything matches over on this side. And so our parabola looks like this. Okay? So if you can remember this basic parent function, then it's easy to graph these things. For example, if we're asked to graph f of x equals negative x squared plus 1. Okay, first of all, I notice that we have a negative in front of x squared, so I know it's going to be concave down. And a is 1, so it's going to follow our 1, 1, 2, 4, 3, 9 pattern, but going down. And then the plus 1 is going to bump everything up 1 unit. So instead of starting at the origin, now I'm going to start at 0, 1, and then I'm going to go 1, 1, 2, let's see, 1, 2, 3, 2, 4, 3, 9, and then by symmetry I just match these points over here, and there's my graph. Okay, what's happening with this one? Now we're moving to the left 4 and down 5. So I'll draw my axes. And instead of having my origin at 0, instead of having my vertex at 0, 0 at the origin, now I'm going to go to the left 4. 1, 2, 3, 4, down 5. 1, 2, 3, 4, 5. A is positive, so it's concave up. I'm going to go 1, 1, 2, 4, and then back 1, back 2, up 4. And there's our graph. Okay, now here a is positive 2, so it's concave up, but it's increasing twice as fast. So my origin is my vertex, and instead of going to 1, 1, I'm now going to go to 1, 2, because every y value is going to get doubled. Instead of going to 2, 4, I'm going to go to 2, 8, because every y value is getting doubled. So it's increasing twice as rapidly as normal. Oh, that's kind of ugly, isn't it? Let's clean that up. Here we go. Okay. So that's how you can graph parabolas using transformations, and if you know this basic f of x equals 1x squared. Okay, now the standard form of a quadratic equation is f of x equals a times x minus h squared plus k. And the reason we like this form is because the vertex is always at hk. Now here's the thing to watch out for. Notice it's always x minus h. Okay, x minus h. So let's convert this to standard form. And we're going to use completing the square to get there. So I'm going to factor out a 2 from the x terms and leave that 22 out here by itself. Okay, so to complete the square, I'm going to take half of negative 6, which is 3, square it, which is 9, and I've really added 2 times 9, which means I've added an 18 to keep it balanced. I'm going to have to subtract 18. So I get 2 times x minus 3 squared plus 4. And so that means that our vertex is at 3, because remember it's x minus h, so h is positive 3, comma 4. So that's how you find the vertex from standard form. Okay, now a quick way to get the vertex, if you're in standard form, is to realize that the vertex of a parabola always occurs at negative b over 2a. And to get the y-coordinate, you just plug that number in. So here's the shortcut. Negative b over 2a is going to be positive 4 over 2 times 1, which is 2. So that's the x-coordinate of the vertex, that's h. And the y-coordinate is going to be f of 2, which is going to be 2 squared minus 4 times 2 plus 3, which is 4 minus 8 plus 3, which is negative 1. So our vertex is at 2 comma negative 1. So that's a really handy shortcut to remember if all you're looking for is the vertex. Okay, so what happens if we know the vertex and a point but we don't know the equation? Well, in this case we're given that the vertex is negative 2, 5 and it passes through the point 0, 9. So that means that f of x is some number a times x plus 2 squared. Now why did I do plus 2? Because it's x minus h and it's x minus a negative 2 plus k, which in this case is 5. So we need to find a. Well, I know that when x is 0, f of x is 9. So 9 is going to equal a times 0 plus 2 squared plus 5. Subtract 5 from both sides, and I get a is 1. So now we have our equation. F of x equals 1 times x plus 2 squared plus 5. And that's how you work with quadratic functions and parabolas.